Welcome back to this plenary session in GRA6036. Today is Monday, March 23rd, and we are doing project 11. So we're now to start exercise D. But before we start this exercise, just want you to notice one thing is that maybe some of you saw it, that there is a typo here. I mean, the name of this variable is not look, but looks. So I mean, if you look at the dataset, we see that here it's called looks, while this seemed to work even though we misspelled it. And so I was a bit puzzled by this myself, but the reason seems to be that when you do the $sign thing to enter the variable name of a dataset, it's okay to misspell it if you just forget the last letters of the word. So to see what I mean, if you take BTY, there is here is a variable called big city. So of course, if you write big city, you get the big city indicator. If you write by city, you get nothing. But if you write big sit, you get the same variable. So I mean, if you abbreviate the names in this manner, I mean, it doesn't really matter. But I mean, it's a nice thing to write out the full names anyway. So let's do looks. Okay, so we are here, and in exercise D, we are to create, let's see, two new data frames. So one data frame for the good-looking people and one data frame for the not so good-looking people. So let's call that BTY GL, which is then BTY square brackets BTY $sign GL equals 1. So that's for the good-looking people. And then we have the not so good looking people, so a new data frame BTY not so good looking, and that's when the good looking indicator equals 0. So now we have these two data frames. We can have a look at them to see if everything is correct. So not summary, but head. So here we see that for the good looking people, the GL variable is equal to 1 for all of them. And for the not so good looking people, it's supposed to be 0 for all of them, which it is. So now we have two data frames, and we are to plot the log wage versus years of experience for both these groups. So we are to make two plots. So that's plot BTY-GL, and there is a, let's see, so okay, so here we see that there is a variable called experience, exper. So we can use, we're supposed to have that one on the x-axis, and then BTY GL $sign log wage on the y-axis. So here's a plot, and we'll make this plot nicer by changing the names that you see here. So and here. So on the x-axis we have years of experience, and on the y-axis we have log wage, and then we make a heading, so we know that these are the good looking people, and then we can remove the frames, which is nicer. So we take frame plot false, so now then we get this plot, which is better. And now we do the same thing for the not so good looking people, so then we can just copy this and change not so good looking, not so, and here not so good looking people. Then we have two plots, and we want these two plots in the same figure, so then do par mf row equals c 1 2. Let's try that. So here we are. And here, I mean, now notice that the y-axes are not the same in the two plots, so we want to adjust this y-axis, or both of these, so that they are more immediately comparable. Then let's check, so what is the max on the log wage scale, so we do max BTY log wage is 4.3. So then we can do ylim. See, we start at 0 and we want to go all the way up to 4.5, say, for both plots. And now we see that the y-axes are the same, so these plots are easier to compare. Okay, and then we're asked if the trends seem linear in the two plots. So well, not really. There seems to be some curvature in both of them, which tells us, you have to look closely, of course, to see that, and it helps knowing that we're in the next exercise are going to fit a linear regression model with experience squared. But I mean, knowing that, at least we can sort of see it, and this is the kind of but where at least you should try such a model and see if the experience squared, the coefficient on that covariate, is significant. So okay, so that is, now we go into exercise E, where we are to fit a model with experience and experience squared for both data frames. So that's E. So we do fit good looking, and the log wage is our y. So and then we do tilde exper plus, and now we need the I because we're going to square this thing. So if we don't wrap it into this y function, we get an error. And we fit this model, and we do the same thing for the not so good looking. So that's BTY, we replace. We have to get the correct data frame. So not so all over the place. And now we fitted these two models, and we can have a look at them. So we do fit GL and fit NSGL. So here we are, and we see that in both of these, the squared term, or the estimated coefficient on the squared experience squared are significant in both places. So this tells us that, well, in this data there seem to be some not a linear effect of experience, but a curved effect. So this squared term serves a purpose, and we can now add these add the fitted regression lines to both these plots. So if we go and have a look at them, we see that, well, so we want to add lines to these plots. So let's copy this code, paste it here, and we see that. So let's have a look at max BTY exper 48. So that tells us that when we want to make a line, we can start counting at 0 all the way up to 48. Then we make an auxiliary variable sequence from 0 to 48 with this step length. So that's 2. No, that's 2. That's from and by, if you want. So do this, then we get this thing. And do also remember that fit GL to look at the coefficients. We can write coefficient. So we get, by doing this, we get the first one, the intercept, second one, and the third one. And now we can write here lines UU. We copy this, so this is then should be the intercept plus beta 1 times UU plus 3 times UU squared. And we do the same thing for the second group, so then we only have to get the correct coefficients. So replace GL by NSGL. And if we want this color red, have it in, and we make it a bit wider, so line width 2. do that both places. This. Now we run the whole code, and we added these fitted lines to both plots. So, well, well, in the next videos, I'll continue this project.